Hello friends, welcome back to Skill Raptor. So today we are going to see the concept of selectivity and how we use that selectivity to write a basic flow sheet. For that we are going to use a hydrodealkylation reaction of toluene which gives benzene. Before I move ahead, I would like to request you to please kindly subscribe to this channel and like the video if you really enjoy the content and find it useful. So moving ahead, so what is the hydrodealkylation of toluene? So most of the things are being expressed in the name itself. So toluene plus H2 gives benzene plus, you can guess it, yeah, it's CH4. But what interestingly happens in this reaction and why we are taking this for this subject is because the benzene degrades. It gives the byproduct that 2-benzene gives diphenyl plus H2. Now, when you are designing a flow sheet for such a reaction, we need to take care that there is a byproduct which is getting formed. So let me tell you what exactly is happening. So toluene, say it's 1 mole which is given in. So X fraction is converted into benzene and Y fraction, which will say 1 minus X, which is not converted, this needs to be refluxed. Okay. Now let us move on to, this is a basic stoichiometry if you can appreciate that. Now let us move to what exactly the selectivity is and how selectivity is useful in writing a flow sheet. Talking about selectivity, there are various definitions for selectivity and how they are written. But selectivity is generally given by moles of desired product. Here it is benzene. Here it is benzene upon moles of toluene, which is a limiting reactant here, moles of toluene which are converted. So in simple language, selectivity refers to the fraction of reactant converted that ends up as desired product. It's a fraction of reactant which is toluene here, and that ends up into desirable product. So definitely there is something which is undesired that is also formed, so that is called as selectivity, which is lost selectivity, which is given by 1 upon 1 minus S. Now if we know the reaction that toluene, I will write this in the short, H2 gives benzene plus CH4 and 2-benzene, that is whatever benzene is formed, the half of that is converted into diphenyl plus H2. Now based on that selectivity, how are we going to write the amount of benzene which is formed? Now if you can appreciate, the selectivity is nothing but moles of desired product upon moles of toluene converted. So if S is the moles of desired product upon moles of toluene converted, then if I multiply this with X, which is the moles converted. So you can see my numerator and denominator here, it is getting cancelled and we get the moles of desired product, that is benzene, which is formed. Now similarly, how to write toluene? Sorry, how to write diphenyl? Moles of toluene which got converted on the basis of benzene, which is a loss in selectivity was 1 minus S. This is what is getting actually converted into the toluene, into the diphenyl finally. But since, as I said, that whatever benzene is formed, so 2 benzene is giving diphenyl, which means stoichiometrically half of the amount of benzene is getting formed. So 1 minus S upon 2 into X is the diphenyl which is formed in the reaction. So these two things are very important to understand. Let me explain you once again what exactly I did. So selectivity is nothing but moles of desired product, which is benzene, which are formed by the conversion of toluene. So that is S, and X, if you can appreciate in the last slide, we said X is what is converted into the desired product, into the product. So I am multiplying that with X to get the moles of benzene. And similarly, since S is based on benzene, so selectivity lost, whatever is lost is getting converted into diphenyl, but that is half of the benzene that is formed. And that's the reason I am dividing it by 2, and again I am multiplying it by X because that is the toluene which finally got converted. Now let us write the flow sheet now. This is the reactor. Now in reactor I am giving toluene. So X mole of toluene is fed in the reactor, and what is formed? What gets out? Toluene 1 minus X, because the X is getting converted. 1 mole if I feed, then X is getting converted and 1 minus X is getting out. So out of that, benzene is formed Sx. So B I am getting, and diphenyl, that is D, I am writing here 1 by 2 into 1 minus S upon X. Now this goes to separator. Now these are the streams which are mixed. This is a separator column, and it gives you benzene and diphenyl which are separated, which is nothing but S into X, that is selectivity into X, and diphenyl is 1 minus S. But we said that something has to be refluxed as well. So this is a reflux stream. How much is reflux? Is 1 minus X. So this is the whole reaction or reactor analysis we did. Now moving ahead, we will be also building upon different things. That is, what is the recycle? What is the purge? That will make this complicated. But if we go step by step and try to understand every step, I think it will be easy. So in upcoming lectures, we will be doing that. Till that time, if you have liked this video, please kindly subscribe to this channel. Please kindly subscribe. Definitely like the video if you found the content useful, and please comment with your suggestions if any. But definitely don't forget to subscribe this channel. Thank you very much.